Hello, in this video we're going to go over problem B4 from Putnam 2015. So here's the problem. It asks us to find a sum given that the sum is the terms of the sum are 2 to the power of a over 3 to the power of b times 5 to the power of c, and a, b, c are positive integers for which they are sides of a triangle. Okay. So let's look at this one. So first of all, if you look at this one, you can think about this one as a triple sum. And what I need is to figure out what is the restriction on ABC for them to be sides of a triangle. We know that three numbers are sides of a triangle if and only if they satisfy the triangle inequality. So let's just start with that. So A, B, C are sides of a triangle if and only if a is less than b plus c, but it's more than absolute value of b minus c. So that makes me hopeful, because then I can just take the sum as a triple sum and then find each one of them as a geometric sum, because if you ignore b and c, this one would be a geometric sum. And then we do the next one and the next one. It looks like it shouldn't be that much of a difficult problem given that we know the formula for the geometric sum. Although I'm a bit worried about this absolute value, so we'll see what we can get to, what we're going to get to after evaluating the sum for A, and then we'll see what we get. Okay, so the sum of A, B, C in T of 2 to the A over 3 to the power of B, 5 to the power of C is equal to the sum. B can be anywhere from 1 to infinity. C can be anywhere from 1 to infinity, but there is a restriction for A. So A would be from B minus C plus 1, absolute value of B minus C plus 1, all the way to B plus C minus 1. And the summand clearly remains the same. Now, B and C do not depend on A, so we can take that out. So we're going to get B equals 1 to infinity, C equals 1 to infinity, 1 over 3 to the b, 5 to the c, and the rest is a geometric sum. So it's a geometric sum. The first term is 2 to the power of absolute value of b minus a plus 1 minus the term after the last, which is 2 to the power of b plus c, over 1 minus common ratio. So this is the geometric sum. So that way we could get rid of a. Okay, so that's good. So now we turned a triple sum into a double sum. Let's distribute and see what we get. So sum b equals 1 to infinity, sum c equals 1 to infinity. I'm gonna swap the numerator, the terms of the numerator, and the terms of the denominator, because the denominator is -1, and that gives me 2 to the power of b plus c over 3 to the power of b, 5 to the power of c, minus 2 to the power of absolute value of b minus c plus 1 over 3 to the power of b, 5 to the power of c. The first sum is not very difficult to evaluate. So the sum of 2 to the power of b plus c over 3 to the b, 5 to the c is equal to, I can take the 2 to the power of b and 3 to the power of b out. So I would get b equals 1 to infinity times the sum 2 to the power of c over 5 to the power of c, c equals 1 to infinity. This inner sum is a geometric sum, and the outer sum is also a geometric sum. So that would be the first term over 1 minus common ratio times the first term over 1 minus common ratio. So if you want to see exactly how this process works, I have a video on these types of sums. So I'm going to put it on the screen. You would want to check that out. So the first one becomes 2/3 over 1/3, so that's 2 times, and that one becomes 2 over 3. So that sum is 4/3. So this is the first sum, this sum. This sum is 4/3. Now let's look at the second sum. For the second sum, I don't know whether b is larger or c is larger, so that changes the sum in terms of the absolute value. So let's take two cases. You have the sum of b equals 1 to infinity, c equals 1 to infinity of 2 to the power of absolute value of b minus c plus 1 over 3 to the b, 5 to the c is going to be, it is b equals 1 to infinity, sum c equals b to infinity. This is the case where c is larger than b or equal to b. So this is c minus b plus 1, 3 to the b, 5 to the c. If b is larger, then it would be sum from c equals 1 to infinity and b equals, so b cannot be c. We already took care of the case when b and c are the same. In this case, b is larger than c. So it would be the sum from c plus 1 to infinity, 2 to the power of b is larger, so this would be b minus c plus 1, and then 3 to the b, 5 to the c. Now, we can evaluate each sum using the geometric sum. This is a geometric sum, the first sum. This is, these are terms of a geometric series. So it's the sum b equals 1 to infinity. It is the first term. The first term is when c is b, so it's 2 over 3 to the b, 5 to the b, over 1 minus common ratio. Common ratio is 2 over 5. So that's the common ratio. Plus, the second sum is also a geometric sum. The first term is when b equals c plus 1, we get 4 over 3 to the c plus 1 times 5 to the c. So that's the numerator if you plug in b equals c plus 1. And 1 minus common ratio is 2 over 3. Okay, so these two are going to be evaluated again separately using the geometric sum. The first sum is 2 over, so the denominator is 3/5, so that's 10/3, times the sum 1 over 15 to the b equals 1 to infinity, plus the second one is 4 over 1/3, and then the sum c equals 1 to infinity, 1 over 3 to the power of c plus 1, 5 to the power of c. So that's equal to 10/3. Okay, so this is the first term, which is 1 over 15 over 1 minus common ratio plus 12 times first term, which is 1 over 9 times 5, divided by 1 minus common ratio, which is 1 over 15. Okay, so now we're going to evaluate this one, and then that should give us the final answer. So 10/3 times, this is 1 over, if you multiply both numerator and denominator by 15, we get 1 over 15, plus if you multiply the numerator by 45, you get 12, multiply by the denominator by 45, we get 45 minus 3. Simplifying that, this is going to become 5, this is going to become 7, so we get 5 over 21 plus 12 over 42, 5 over 21 plus, they have a common factor of 6, so this divided by 6 is 2, that's 7, so that is 2 over 7. This becomes 11 over 21. So the final answer is we take what we found here, 4/3, and then we have to subtract this quantity that we get. So the answer is 4/3 minus 11 over 21. 4/3 is 28 over 3 minus over 21, and this is 11 over 21, so that's 17 over 21. And that is the final answer. So if you like this video, make sure to subscribe to the channel where you can find more videos like this. My focus is on working on preparing students for math competitions. So click on one of the videos on this screen, and I will see you in another video.